Hi, so this is the second video in the Wireshark forensic analysis, and we're going to go through a few techniques here that you can use to narrow down or discover what's going on. And so the first technique is attacking the attack. When we looked at that, we looked at the PCAP, 780 some frames, and so how do we even start figuring out what's going on there? So the beginning always I think kind of starts the same way. We have statistics that we looked at, I believe, a couple videos ago. Endpoints and conversations are the two statistics that help you kind of start figuring out what's going on. And then we have a technique called colorizing TCP streams and following TCP streams. And these are both built into Wireshark, and they help you start understanding patterns and just kind of give, once again, you're trying to get a global view of what is going on with this attack. And so we use these tools to uh, help us get our arms around it. So we will go to the same PCAP that we looked at in the first video. And so one thing that we can do is, if we scroll down, the length of the frame can tell us a lot. So if we scroll down the length, these frame lengths here, the smallest frame you're going to see is about 50 bytes long. And the fact that these are all in that really low range shows that there's a lot of short frames being exchanged. And so this is not and they're all TCP too. Looking at the protocol, if you go down this entire frame capture here, everything is TCP. And so this is not a web kind of an attack. This is and it's not really a TCP attack, probably, because, well, we'll see why not. But we are just using TCP as a protocol. So I don't think the TCP is the evil doer in this case, but it is the protocol that's being used. And so anyway, so if we go to statistics and we go to endpoints, we see, so it's Ethernet. Okay, we have no IPv6. IPv4, we see two endpoints. We see .111 and .114. So these are the only 2 points that are concerned with this particular attack. And V6, nothing going on with V6. But if we look at TCP, we see each of these represents a TCP conversation. You remember TCP is a connection-oriented protocol. So here's where understanding protocols, is important when you use Wireshark. TCP is connection-oriented, and evidently it has set up multiple connections. You look at the bytes transfer of 558,000 bytes, and then almost 3,000 K bytes, but then or 3,000 bytes, I'm sorry, and then we look at the series of frames here, or not frames, but conversations here, and wow, 91K, 91K, 94K, a lot of similarity between those. So something looks like these conversations look fairly periodic. They look very similar in nature, and so that is kind of giving us a clue. So Uh, so going to the statistic uh, is helping us understand maybe a tiny bit of what's going on. So there's a technique called stream colorization. So let's go up to this very first frame here, and we go down and we say colorize conversation, and we're going to pick. Okay, so we know everything's IPv4. We know everything's Ethernet. That's not going to help us much. But we saw that TCP, we had multiple TCP conversations going on. So that's probably the best way to categorize this. So we're going to give it color 1, and now things really kind of get interesting. Okay, we have a lot of color 1, a lot of this first stream going on, and if you look at TCP, we're going to see it's stream 0, and if you look at the side here, this is kind of shows a condensed version of what's going on, but here we have stream 0, stream 0, stream 0, stream 0. So once again, we kind of like we saw in the statistics, we see a somewhat periodic characteristic to this. So let's move now. This is part that have not colorized yet, and these are still some small frames, but all of a sudden now we start seeing larger frames here. And we see this large frame pattern, 15, 14, 642, 54. Now we see another one of the command and control streams, and well, okay, I guess we don't know that, do we? Or maybe we don't. Let's go up here, and we're in this first stream that we identified, and let's do something called follow the stream. So we're going to follow the TCP stream. Two things happen here. First, it filters it applies a filter, TCP stream equals 0. We saw that just a second ago. And then it only displays those frames. And so we see sequentially numbered frames, and then we see a gap there, and then we see a few sequentially numbered frames, and then we see a gap, and now we go to the 200s and a gap, and we go to the 300s and a gap, and we go to the 400s. And so we are seeing this stream, once again, the intermediate and periodic nature of the stream. Now we can just go down this stream and look and see what we see down here. So we'll go to the first frame, we'll go to the second frame, third frame, fourth frame. So that's interesting. We have some more text, and it's a little different than the text that was triggered on. There's the text that was triggered on. Now we see it repeatedly, but here we see ANABLIGI. So that's another one to put in our notes. So we have ANABLIGI and BAGLIMI. So we want to write both of those down into our notes. So this kind of looks, so it's repeating, and it's repeating the same frame. And okay, there's another ASCII. And now this is something that we can read, and it's CA. The space here is just to help you kind of your eyes trace along. It doesn't mean that there's necessarily a space there. That's why there's a space between the A and the P. But this is readable, and it says cap screen, and so we're starting to get an idea of maybe what's going on with this. So we have a BAGLIMI, and then we see this cap screen, a BAGLIMI, and this cap screen. So this kind of looks like in an attack, something, a command and control kind of a thing. So we're going to take that filter off here, and we'll move up. And so I'm going to go into, you could use any of these frames. I tend to go to something that, since the smaller frames were command and control kinds of things, even though this looks like just a normal TCP thing, I'm going to go into a little larger frame here, and I'm going to say colorize the conversation, and it's TCP, and we're going to use color 2 now for this. And we're going to go down, and now we're back into our gray area again. Pick another 15, 14 frame, colorize conversation, TCP. We're up to color 3 now. There's another break, and we'll just do one more colorize conversation. At this point, we probably color 4. We probably don't need to do that, but we're, I guess, kind of making the point here. So. So here, once again, on the side over here, we see this pattern of, here's our colors, here's our this command and control, this possible command and control, and we see the periodicity there. And so we followed the command and control stream, the possible command and control stream. We go down here, we know that anything in this color is part of this TCP stream, so we can just go ahead and go to the first frame, and we can say follow TCP stream. And of course, in the main window here, we essentially just have zeroed in on that one color. But since we colorized it, we don't really need to do it that much, or it doesn't help us that much. But when this window opens up, we see some interesting things. We see the anabilgy. Purple is inbound. Red is outbound. And so this gives us an idea of who the attacker is and who the attackee is, who the victim is. We also see cap screen. Yeah, but a little more detail here. See Windows, JPG, and then the EVE hook.dat. Don't really know what that is. And then there's just, there's quite a bit of sort of random looking stuff here. Now you remember, so here are all the frames associated with this particular TCP stream. A standard Ethernet frame is 1518 bytes long, and so when you have information flowing that is longer than 1518 bytes, it has to be broken up into packets or frames, and TCP sends it out, puts sequence numbers on it, and to the other end, TCP is responsible for reassembling it back into one hunk of data that it can then pass up the OSI stack. And so that is why you're seeing so many frames here, but this particular window concatenates all of those frames and shows you the entire conversation essentially. There's one other interesting part about this, and that is right here. This JFIF. We see cap screen and we see JFIF. If you've been doing this for a while, you immediately recognize what that is. If you haven't, then I'm afraid you're going to have to wait for the next video.